integration by parts, we're going to basically come up with this formula up here. It's based on the product rule. When we take the derivative of two functions being multiplied together, in the textbook they use u and v, you could call it f and g if you prefer, we know that we'll get the original function u of x times by the derivative of the v, in this case, plus the derivative of the u of x times by your v of x. Now, you know how they get this integration by parts formula is they basically integrate everything, each term, this guy, and this guy. By taking the integral of all these terms, this one here becomes just u of x times v of x, and then we have the two integrals here. And what they ultimately do is just rearrange it so that they get u of v of x by itself, which is this term right here. So to both sides, we're going to subtract off this integral to both sides, and that's how we get this overarching integration by parts formula. So I've included up here the integration by parts formula that we just showed on the previous slide, just for reference. Now if you notice, there's two functions that we have to work with. So we have to be able to identify and come up with these two functions, and that's probably the hardest part. We need to figure out what u of x is going to be and which one's going to be v prime of x, so the derivative. So in this particular case, let's just start off and let's call this one x. So this function right here. That means then the derivative is going to be our cos 4 of x dx. Now, we can easily find the derivative of u of x. It's just going to be 1. So that makes it quite nice for plugging in here, because that will eliminate one of the two terms that are being multiplied together. Basically, a 1 times anything will just give us the original v of x. Then we have to figure out what our v of x is going to be. So to do that, you have to take the integral. So the integral of cos 4x dx, we know that if we set our u to be 4x, our du is going to be 4 dx. Isolate for dx. We then get 1 over 4 integral of cos u du. 1 over 4 sine goes to cos, so cos goes to positive sine of u. And if we plug in our u of 4x, we get that. So we're working with this sine 4x. Now technically it's plus a constant as well, but keep in mind we're plugging it into the integral formula, so we don't need to worry about the constants. So if we actually look at writing this all out then, this function here, the integral of this function, is going to be u times by v, so it's going to be x, our u of x, times by our v, which we just figured out, minus your integral of u prime, which is 1. That's the advantage of using this as our u function, because when we take the derivative, it simplifies it, times by v of x, which is, so we don't need the 1 here, we can plug in then just 1/4 sine of 4x dx. So we get that. So this portion's nice and easy to work with. Now we have x over 4 sine 4x minus, we move the quarter outside, the integral of sine 4x dx. Let our u be 4x. du is going to be 4 dx. Again, divide by 4, divide by 4. So we're going to then get x over 4 sine 4x minus, and if we substitute in here u and our du over 4, we actually get 1 over 16 integral of sine u du, and then plug in sine u. The integral of that becomes then, so sine goes to the negative cos, so plus 1 over 16 cos of u. U in this case is 4x plus c. So now comes the harder part of actually figuring out when you need to use this versus using different techniques. In this particular case, we could look at splitting this one up and trying to set this to be our u, this to be our v prime, and then taking the integral of this. But to take the integral of our ln, it's not so nice. So what we're going to do is use the techniques that we know so far first. So let's say u is going to be sine x, because we can see that this is being plugged inside of another function. So then our derivative of this is going to be cos x dx, which happens to be right here. So that's nice. We can now say the integral of ln of u du. Now again, we've got the integral of a ln. So now again, not so nice, but let's see if we can try to figure this out. Now we're going to try looking at integration by parts to see if that will help us at all. Now you might be wondering why I want to do integration by parts here, because you can only really see one function. But technically, we could have our u of x be ln of x. We'll just use x for my variables on the side here. And my v prime of x could be 1. Ln times 1 is still ln, right? So that way, when we take the derivative, we get 1 over x, which we can find quite easily. And for v of x, we're going to go up a degree, so we're going to get x. Then if we use this formula here, we now have our u of x and our v of x. So we can write it as the integral of ln of u du is equal to u of x times v of x in terms of the u variable here. So it'll be ln u times by u minus your integral, and then we have v prime of x, which is 1 over x, or 1 over u in this case, 1 over u times by our v of x, which is x, which is just going to be u du. So, nice thing about this, we now have u ln u minus, you notice this cancels out, so we have the integral of 1 du, which then becomes just u plus c. Now keep in mind, from this point down, we've been using u substitution here, so we still have to do a u substitution. So we now have sine x ln of sine x minus sine x plus c. So this is our final solution. Now, one thing to notice about this as well, if you think back to why we use integration by parts, is because it's based on a product. If we consider this without our plus c, we can actually see that sine of x is multiplied by ln of sine x minus 1. So that's technically our product plus some constant outside. Hence why we have the product rule.